A person leaves home and walks 2 miles west and then 4 miles southwest. How far from home is the person? And also, in what direction must the person walk to head directly home? We want to give the answer in degrees north of east. So we'll model this using vectors. So if a person walks 2 miles west, or in this direction west, we can model this piece of the walk using this vector here. Notice how the direction is west, and because the person walked 2 miles, the magnitude of this vector would be 2. So if we call this vector v sub 1, we can say that the magnitude of vector v sub 1 equals 2, and the vector would be in this direction. Next, the person walks 4 miles southwest, which would be in this direction here, and therefore we can model this piece of the walk using this vector, where notice how the direction is southwest, and because the distance is 4 miles, if we call this vector v sub 2, we can say that the magnitude of vector v sub 2 equals 4. So to determine how far the person is from home, we would want to find the magnitude of the resultant vector, or the sum of these two vectors, which would be this vector here. So if we call this vector r, our goal is to find the magnitude of the resultant vector, where again the resultant vector would be the sum of these two vectors. So to find the resultant vector, we'll write vector v sub 1 and v sub 2 in component form, then find their sum, then find the magnitude of the resultant vector to answer this first question about how far the person is from home. Let's first write vector v sub 1 in component form. Now because the direction is west, we should be able to recognize that the x component of the vector would be negative 2, and the y component would be 0. Now for vector v sub 2 though, for the x component, we'll use x equals the magnitude times cosine theta, and the y component is equal to the magnitude times sine theta. Where we know the magnitude is 4, but we'll have to determine theta, where theta is a direction, when the initial point is at the origin. So notice how if the direction is southwest, theta is measured from the positive x-axis, or this axis here. So notice how theta would be equal to 180 plus 45, or 225 degrees. So the x component would be 4 cosine 225 degrees, and the y component would be 4 sine 225 degrees. Now let's determine these trig function values. To do this, we'll sketch a reference triangle using the terminal side of our angle theta. So the reference triangle would be this triangle here, and we should be able to recognize this would be a 45, 45, 90 reference triangle. So we know the relationship among the three sides would be 1, 1, square root 2, but because we're in the third quadrant, both the x component and y components would be negative. So using our reference triangle, cosine 225 degrees would be equal to the ratio of the adjacent side to the hypotenuse, which would be negative 1 divided by square root 2. Notice if we rationalize this, though, we would have negative square root 2 divided by 2. So for vector v sub 2, the s component would be 4 times negative square root 2 divided by 2. And then for sine 225 degrees, that would be the ratio of the opposite side to the hypotenuse, which is still negative 1 divided by square root 2, or negative square root 2 divided by 2. So the y component is also 4 times negative square root 2 divided by 2. So simplifying, vector v sub 2 would have an x component of negative 2 square root 2, and the y component would also be negative 2 square root 2. Okay, so now that we have vector v sub 1 and vector v sub 2 in component form, to find the resultant vector, we'll find the sum of these two vectors, where again, vector r is equal to vector v sub 1 plus vector v sub 2. Let's find this sum on the next slide. So the resultant vector is equal to Adding the x components, we'd have negative 2 minus 2 square root 2. Adding the y components, we just have negative 2 square root 2. Now again, to find the distance from home, we want to find the magnitude of vector r. So we would take the square root of the x component squared plus the y component squared. And now we'll go to the calculator. So we have square root, and then in parentheses we have negative 2 minus 2 square root 2, right arrow, close parenthesis, squared, and then plus, in parentheses, negative 2 square root 2, right arrow, close parenthesis, and squared. Enter. So the total distance from home would be approximately 5.5959 miles. So this is the answer to the first part of the question. And now for the second part of the question, we want to determine in what direction must the person walk to head directly home. So notice how I sketched the resultant vector on the coordinate plane this time. If the person wants to walk directly home, they would walk in the opposite direction or in this direction here. So we're looking for this angle here, we'll call it angle alpha, which would be the number of degrees north of east. Again, we just found the resultant vector has an x component of negative 2 minus 2 square root 2 and a y component of negative 2 square root 2. And we know that tangent theta would be equal to y divided by x. So if tangent theta is equal to negative 2 square root 2 divided by the quantity negative 2 minus 2 square root 2, this tells us that theta would be equal to, if we take the inverse tangent on both sides, this would be theta equals inverse tangent of this ratio. Now remember, our angle theta, this angle here, is actually in the third quadrant, but remember the range of inverse tangent is from negative pi over 2, is the open interval from negative 90 degrees to positive 90 degrees. And since tangent theta is positive in both the first and third quadrants, this inverse tangent function value should return our angle alpha, which would be the number of degrees north of east. Let's go ahead and give it a try. We do want to make sure that we are in degree mode, so we'll press the mode key, go down to the third row here, highlight degree, press enter, and now back to the home screen, and we'll press second tangent, and then the numerator in parentheses would be negative 2 square root 2, right arrow, close parenthesis, divided by, in parentheses, negative 2 minus 2 square root 2. Right arrow, close parenthesis, and another close parenthesis, and enter. So again, notice how this angle is in the first quadrant, so it is the angle we're looking for, or the number of degrees north of east, for this person to head directly home. Notice how the direction of the resultant vector would actually be this angle plus 180 degrees. So we'll say our angle is approximately 30.3612 degrees north of east. I hope you found this helpful.